Good morning everyone, this is Rajasuji from first MSc Physics. In this video I am going to explain about the proof of finding the mean of binomial distribution. So these are the topics which I am going to explain about it. First let us see about the introduction. So the binomial distribution is a fundamental concept in probability theory, modeling the number of successes in a fixed number of independent trials, and a crucial aspect of understanding the binomial distribution is finding its mean, which represents the expected value of the random variable. And what is binomial distribution? So it is a discrete probability distribution that models the number of successes in a fixed number of independent trials, each with a constant probability of success. And it is used to analyze the experiments with two outcomes, like coin experiments or medical trials. So what is mean binomial distribution? So it is defined as the expected value of the number of successes in a fixed number of independent trials, and it is denoted by mu and calculated as mu is equal to np, where n is the number of trials and p is the probability of success. So this formula represents the average number of success that can be expected in repeated trials. The mean is a measure of a central tendency, and it is used to describe the long-term behavior of the binomial distribution. So why we need to find mean in binomial distribution? Because it gives the expected value, which means the mean represents the expected value of a random variable, which is essential in decision making under certainty. Now let us see about the proof of mean of the binomial distribution. For a binomial experiment, the probability of success in n trials is written as the NCR p power r q n minus r. So here the mean formula can be written as summation r is equal to 0 n r power n cr p r and q n minus r. In here we are substituting the value of n is equal to r is equal to 0, so first term becomes 0, and next nc1 pq n power minus 1 plus 2 nc2 p power 2 q n minus 2 and plus 3 nc3 p power 3 q n minus 3, and going on plus n power n c power n p power n q n minus n. Here the first term is 0, so the next term will be np q power n minus 1 and plus 2n c2 p power 2 q n minus 2 and plus 3n c3 p power 3 q n minus 3 plus going on plus n p power n. And next step, np q power n minus 1 and plus 2. Here the c2 nc2 can be written as n into n minus 1 by 2 factorial, and nc3 can be written as n into n minus 1 n minus 2 by 3 factorial. So by cancelling the two terms in above equation, we get the equation npq n power minus 1 plus n into n minus 1 p power 2 q n minus 2 plus n into n minus 1 n minus 2 by 2 factorial p power cube q n minus q plus going on plus n p power n. Here we are taking n power t as a common term. After that this term came, and here n power np into q plus p into n power minus 1. So when we expand q power p into n minus 1, we get the above binomial series, and also p plus q is equal to 1. By substituting this value in q plus p into n minus 1, we get the n into p. Hence this is the mean of the binomial distribution. Now let us see about the properties. Here the main properties are scalability and consistency. Scalability, it is the mean of the binomial distribution is scalable, and meaning that it can be scaled up or down by changing the values of n and p. And now consistency. The mean of the binomial distribution is a consistent estimator, meaning that it converges to true mean as the sample size and increases. And now the applications. So uh, binomial distributions have various applications in various fields. Here I mentioned some of the applications. That is, the mean of the binomial distribution is used to monitor the number of defective products in a manufacturing processes. By calculating the expected number of defects, manufacturers can adjust their production processes to minimize waste and improve the quality. The mean of the binomial distribution can be used to predict the outcome of uncertain events. And then the mean of the binomial distribution can also be used to evaluate risk and opportunities in various fields. So at the end we came to conclusion that the mean of the binomial distribution represents the expected number of successes in independent trials. It has a numerous application in fields like quality control, medicine, finance, and engineering. Understanding the mean is essential for informed decision making and optimizing system. So here I included some reference. You can search it. And thank you for your valuable time by seeing this video. Thank you.